Now we are going to discuss about the tokenization and its methods and its usages and its various uh, models available in tokenization. So first, what do you mean by tokenization? Tokenization means it will segment then input character sequence into tokens. So for example, consider this is a character of sequence of characters. John is a person dot. So John space is space a space person dot are the sequence of characters. Here we need to split these characters into tokens. So the first approach would be splitting using whitespace. So John is the first word, is the second word, A is the third word, person dot is the fourth word. Here we can't use that person dot for the further processing easily. So for that we need a better tokenization approach. So better tokenization means it need to split this person dot into person whitespace dot. Then only we can use this in output for further processing. That would be handled by using NLP tokenization methods. So we will try to cover those things in the later part of this video. And then second point is tokens can be words, numbers, punctuations and etc. So it can be anything. So tokenization tokens are not only restricted to words, it can be numbers, it can be punctuations, it can be anything. So this is the example of tokenization using NLP. Here you could see the difference between the actual normal tokenization and then NLP based tokenization. So here John Peter comma space. So here this comma needs to be separated. So that's the final output. Here comma is separated using whitespace. Similarly for hold. Whereas in case of NOV November dot, the NOE dot is not separated using whitespace. The reason behind it is it's an abbreviation. NOV dot is the abbreviation for November. So that's why NOV dot is not separated using whitespace. And then 29 dot. So 29 dot got separated using whitespace, 29 space whitespace. So this is called tokenization using NLP example. So you could see the actual difference between the normal tokenization and then NLP based tokenization. Here the NLP based tokenization knows where to split and where not to split. So in the case of NOV dot, it is not splitting because it is the abbreviation for November. Whereas in case of 29 dot, it's not the abbreviation for anything. It needs to be splitted. It needs to be separated. That's why it got separated. So there are three types of tokenizers: whitespace tokenizer, and then simple tokenizer, and then learnable tokenizer. Whitespace tokenizer is it will try to separate the tokens using whitespace. For example, this is the sample sentence: John space is space a space person dot. Here if you use the whitespace tokenizer, the final output would be first token John, second token is, third token a, fourth token person dot. If suppose the output, the final output, which means the four tokens are not very helpful for the further processing because person dot cannot be consumed directly. We need the final output as John first token is, second token a, third token, person fourth token, and then dot is the fifth token. That's our expected output, but when we use the whitespace tokenizer, that won't be the final output. And then simple tokenizer tries to use simple rules to tokenize this sentence into granular tokens. And then learnable tokenizer is the NLP based tokenizer. Here it uses the maximum entropy algorithm to tokenize these sentences into granular tokens based on probability model. This example is based on NLP based tokenization, which is learnable tokenizer. We will try to cover an example about the learnable tokenizer algorithm in the further videos. So thanks for watching.